Hello dear students, today we are going to take up the session on Raoult's law. This chapter is from plus 2 history, chapter number 2, solution. So let us start the session. So first and the foremost, learning outcomes are, you will be able to know about Raoult's law and their numericals. So let us start with the small note. What do you mean by vapor pressure? Partial pressure, total pressure. Vapor pressure is a very small term. When you heat a liquid in a vessel, it will change to vapor. Evaporation, boiling point, you know, these are the two processes which will happen. Evaporation takes place at any temperature. Boiling point takes place at particular temperature. When this vapor pressure is equal to atmosphere pressure, that temperature is called as boiling point. So now my question here is, like, what is the meaning for partial pressure? So because, for example, there are two components, both are volatile. If you are adding that components in a particular vessel or cylinder and you measure the pressure, it will give total pressure. The same vessel, same cylinder, if you remove one gas is left, another gas you have removed, so that is known as partial pressure. So sum of the partial pressure gives you total pressure. So these are the terms: vapor pressure, partial pressure and total pressure. So now we are going to discuss about Raoult's law. Raoult's law is particularly for two areas, like one is both solute and solvent, both the components are volatile, and in the second case one is non-volatile, another is volatile. So let us take the case first for both are volatile components. If A and B are components, so what is the Raoult law statement is, at a given temperature the partial vapor pressure of a volatile component, any component A or B, is equal to product of mole fraction of that component and vapor pressure of that component in the pure state. Mean to say that PA, if you are taking as PA, partial pressure, is the product of vapor pressure into mole fraction. Similarly, if the second component is also volatile, PB is equal to PB naught XB, where PA naught, PB naught are the pure solvents, pure liquids, pure components, and total pressure will be sum of the partial pressure. And if you see the curve is a PX diagram. Now you can see from here XA is 1 written, and we know XA plus XB is equal to 1. When we say XA is equal to 1, XB will be 0, and whatever the partial pressure will be exerted by A will be PA, right? Similarly, if you take in the right hand side, this side of the curve, XA is 0 and XB will be 1, and whatever the pressure will be exerted, that will be for B. And if you add both of the components A and B, that gives you total pressure. So this is the Raoult's law for both volatile liquids. Now let us take up the second case, where one is non-volatile solute and solvent will exert vapor pressure. So basically we know from our practical experience also, let us take the water, and if you add sugar in water, so then what happens is the vapor pressure of that solution will decrease, or we can say boiling point of that solution will increase. So vapor pressure and boiling point are inverse relationship. So now if you have added solute, the vapor pressure of solution will decrease, and of course vapor pressure of solvent, which was pure, that would be more. That's why we have written P naught solvent minus P solution, and this is a relative measure because P naught solvent is always higher than solution. P naught, this is lowering, and if you divide by P naught solvent, that is known as relative lowering of vapor pressure. So when we add non-volatile solute, surface of the liquid is covered. Now less surface area is there for the vapor molecule to leave, so thereby they exert less vapor pressure. And as I have already told, pressure of the solution will be less than the vapor pressure of solvent. So now next term we are going to take up is numerical. Numerical on Raoult's law. If you see the vapor pressure of benzene and toluene. Benzene and toluene are two volatile components, 150 mm and 50 mm. Generally we take as such, like whichever is present in small quantity that we take solute, and which is in more quantity that is solvent. So we are just taking two, that is the both are volatile components. We take components, and solution is prepared by mixing equal weight. Now weight are equal, so they have not given the weight, but you can take W as common item. Okay, and we should be aware of benzene and toluene formula also, so that we can find the molecular mass. So we know benzene formula is C6H6 and toluene is C6H5 CH3. So first and the foremost thing is we will calculate what? We will calculate the molecular mass, and then we calculate moles, and then we calculate mole fraction, and vapor pressure of benzene toluene is given. So let us see how we have to calculate. First we know W is the amount of benzene we have supposed, because W both are same. So then we have divided with the molecular mass, we got the mole fraction, and then we have applied the substituted in the formula, which is P total is equal to partial pressure of benzene plus partial pressure of toluene, right? So this way numerical we can do. Let us try this numerical. So this numerical, you can pause the video and just try from your end. Methanol and ethanol. So you know the formula of methanol CH3OH and ethanol C2H5OH. So we have to find first molecular mass, and you know 32 gram is given, you can find moles, and then 23 gram ethanol given, you can find moles. We can calculate mole fraction, and once mole fraction is there with us, we can calculate the partial pressure of methanol and ethanol, and if you add both of the components, you will get total pressure. Hopefully you will get the answer. Okay, I am going to show you the answer now. So here is the answer, that is 77.37 mm of mercury. What we have understood till now is Raoult's law. Raoult's law says that for a given temperature, partial pressure is equal to mole fraction of that component into vapor pressure of that component. And if you take two components, PA is equal to PA naught XA, PB is equal to PB naught XP. If you total it, pressure of the solution would be PA plus PB and equal to PA naught XA plus PB naught XP. Similarly, the curves we have understood, and we have done the numericals also from Raoult's law. So thank you for watching this video. So please do share this video and download the application for doing the tests and for courses. Thank you.